Okay, guys, I want to continue the previous session. I want to continue the discussion about one-dimensional motion. In this session, I want to talk about instant velocity. What is instant velocity? Actually, instant velocity is the rate of your movement in a moment. So, as we had our average velocity as your displacement over time it takes, here instant velocity, which I would show it without bar above it, equals to limit of average velocity when time is going to be 0. It means that I'm going to, have my movement, how much I would go for what, in a moment. It equals to limit of delta x over delta t when delta t going to 0. It equals to dx over dt, differential of my displacement over differential of my time. It means that the derivative of my displacement function with respect to time, with respect to t. So if I want to show it on a diagram, it would be something like this. This is, let's say, my x, my you know displacement with respect to time. And for example, the diagram it would be like this. And my initial point is here, my final point is here. So if I draw a line between these 2 points, the slope of this line would be my average velocity in this time interval, which is this delta t. But if I, reduce the time interval, for example, to this point, then the line would be tangent line like this. Then the slope of this line would be my velocity at that moment. Here again the same. So instant velocity is your velocity at that moment, at that time. But average velocity would be your velocity all throughout the path you took. So if I want to take an example, for example, let's say if my x would be 3t squared plus t, then v, my instant velocity, would be dx with respect to dt equals to 6 times t plus 1. So for example, um, in 0 second, in the beginning of the movement, I have just 1 meter per second. In the, for example, 2 second, it would be 6 times 2 plus 1, which is 13 meter per second, etc. The other notion I want to talk about is actually, which is similar mathematically, is acceleration. What is acceleration? Acceleration is the cause that you can see our velocity would be different. I mean, when you are, for example, taking a break to slow down the car, you are, actually applying minus acceleration to your car. And vice versa, if you want to push the power, then you will see that your velocity would increase through the time. So you're applying actually acceleration. And acceleration is completely related to um, force, which is another topic that we will talk about it. Again, similar to the velocity discussion, we have also average acceleration, which is again the same I want to show it with a bar above it as Vf minus Vi over Tf minus Ti. The velocity at the beginning of the path I'm taking, the velocity at final point, and the time it takes. So it is delta V over delta T. And we have also instant acceleration. I want to show it with A, just A. And it would be, again, I want to reduce the interval of time. Limit of delta V over delta T goes to 0. And it equals to dV over dt. Great. Now, if I want to show it on a diagram for you, it would be something like this. So this line, the slope of this line would be your A bar. But if I reduce the time interval, this is my time interval, delta t. If I reduce it, for example, to this point, it would be a tangent line to this point. So the slope of this moment would be my A. Here again, the same. For example, in my discussion, which was x was 3t squared plus t, then v equals dx over dt equals 6t plus 1. Then I can also calculate instant acceleration as dv over dt. This would be 0. This will give me 6 meter per second squared. This is the dimension of acceleration, which is important. Meter per second squared. As you can see, this is also meter per second over second. It would be meter per second squared. Okay, that's it. We'll continue the rest of this discussion about one-dimensional motion next session. Thank you very much.